systems undergraduates often experience a harsh friction point. The transition from the structured, predictable environment of a classroom to the actual demands of a technical job interview rarely goes smoothly. In an academic setting, a student can learn to map entity relationship diagrams and apply data normalization rules to clean data sets. But ask that same student to solve a live business problem on the fly, and the cognitive load often causes them to freeze. Universities typically deploy generic career center mock interviews to address this problem. These sessions measure soft skills like professional communication. They do not test a candidate's ability to navigate a technical architecture or perform live logical deduction under the scrutiny of an engineering manager. Closing this gap requires educators to bring near-world experiential problem-solving directly into the classroom syllabus, forcing students to articulate their logic while under pressure. The solution is a segmented simulation model integrated directly into a standard database management course. Logistically, this intervention is strictly constrained. The entire simulation architecture must fit within a single 50-minute class session. To achieve this, the module relies on a highly controlled chronological loop, using recorded video assets to guide students through a sequence of playing, pausing, solving, and reviewing. By systematically converting a standard lecture period into a high-fidelity technical interview simulation, educators replicate the psychological load of the professional world in a safe environment. The first phase dedicates 25 minutes to framing and preparation. We start with a 10-minute block for career introduction, mapping theoretical topics to active job postings, demonstrating how data manipulation language translates to a data analyst or data definition language to a database administrator. Establishing this mapping to the job market secures student buy-in before any code is written. The timeline then moves into the subsequent 15 minutes, a dedicated psychological preparation block. The instructor issues strict parameters. Students use this time to review their notes and mentally adopt the identity of a job candidate waiting in the lobby for their interview to begin. Forcing this deliberate mental shift stops students from treating the upcoming exercise as just another low-stakes textbook drill. The remainder of the class relies on a single instructional asset, a recorded, real-world mock interview. Time constraints dictate strict specifications. The video must run approximately 24 minutes, ensuring enough buffer for students to execute solutions within the 50-minute period. Visually, the recording captures both the interviewer and the candidate with active cameras. Technically, it features live screen sharing. The candidate's coding environment is entirely visible to the interviewer as they type. Combining live human observation with exposed typing forces the watching students to witness real performance anxiety, nonverbal cues, and real-time technical communication. The recorded candidate is presented with a specific scenario. An e-commerce client needs to optimize 4 different marketing channels to identify high-value customers. This diagram outlines the data architecture the students will manipulate. They must use the attribution table, consisting of string and float data types, alongside the user sessions table, which uses string and date time formats. Pairing a multi-table business case with live human performance factors elevates the exercise from a syntax quiz into a strategic, high-stakes challenge. This brings us to the final phase of the class, structured around an execution loop: play, pause, solve, review. Step 1 is play. The instructor starts the video, and the recorded interviewer presents the specific prompt. For example, calculating task 1, average purchase value by channel. Step 2 is pause. The instructor halts the video exactly after the prompt is delivered, suspending the scenario. During this paused state, the students have exactly 7 minutes. Acting as the candidate, they write their own SQL solutions in real time. The critical pedagogical rule here is that instructors must remind the room that these questions have multiple valid paths. This forces students to rely on their own creative logic rather than rote memorization. Step 3 is review. The video resumes, and the recorded candidate reveals their screen, explicitly explaining their specific coding process and logic. Because the students just attempted the exact same problem, they can immediately compare their own strategic choices against the methodology of the recorded candidate. Iterating through this loop shifts the students' cognitive focus. They must prioritize the strategic demonstration of a logical problem-solving process over the simple retrieval of a correct answer. Stepping back, we can see how this 50-minute module fits into the macro architecture of a full 16-week database management syllabus. Week 14 acts as a bridge. utilizing the mock interview to connect basic SQL queries with advanced NoSQL topics. To measure the efficacy of this specific intervention, researchers collected pre- and post-survey data from the 94 participating students. This visualization tracks the psychological outcomes. The first metric shows a measurable increase in student confidence regarding foundational SQL knowledge. The second outcome is an increased intention to continue applying SQL. The final metric reveals a definitive surge in baseline readiness for high-pressure technical interviews. Simulating cognitive load within a safe, controlled academic environment directly translates into professional self-efficacy. The utility of this teaching module extends well beyond SQL or database management. The core structural framework, career framing, mental adoption, and the play, pause, solve video mechanic is entirely agnostic to the underlying technology. Instructors can instantly deploy this modular architecture across many other technical disciplines, scaling effortlessly from Python data analysis to complex network architecture. By engineering classroom time to mirror the operational realities of the industry, educators equip students with the technical proficiency to code and the tactical ability to prove their value